and welcome to my talk today about how to hack companies via their firewall system. My name is René Freingruber, and I'm working as security consultant at ITSEC Consult, so I have one slide here about my company. So ITSEC Consult is located in Vienna, but we have offices all around the world. I think the nearest one to you is in Vilnius, and it's a team of over 70 security experts. We make more than 400 security audits per year, so it's really 70 technical security consultants. And we also have a vulnerability lab where we frequently search for new vulnerabilities in software, and exactly inside this vulnerability lab we had a look at carrier control, which is a firewall where we found several vulnerabilities, and in this talk I want to show you these vulnerabilities. So this carrier control are these firewalls here. It's a firewall with the capabilities of routers, IPS system, VPN gateway, antivirus, and so on. And it is used by about 60,000 companies worldwide. And I will show you now two different ways how you can spawn reverse root shells on this firewall appliance. And from there on, you can then further attack the internal network, on the domain controller, and so on. Or just sniff at the VPN gateway or the traffic. So I will basically demonstrate here two ways. The first one is working with some JavaScript stuff, and it can only be used to attack administrators. But the second one is using some memory corruption stuff. I will mainly talk about the second attack vector, and it can be used to attack basically all carrier control users. Before starting with the real topic, I just want to mention very quickly the difference between security and secure products, because I often see that people are mixing up these two terms. So basically, a security feature or security product is something which adds additional security to it, to your company or to your network, but at the same time, it can be secure or can be insecure. So for example, if you take an antivirus solution, it will protect you from mass attacks, but at the same time, you're increasing the attack surface for targeted attacks or for some advanced attackers. So if I find a vulnerability in your antivirus solution, I can attack you via your antivirus solution. And the same applies for firewalls, endpoint protection systems, and so on. And we have here many, many different examples. So these are just some examples which we found in the last years in our vulnerability lab. So you see here Sophos, semantic endpoint protection, AVG, and so on, Bitdefender or Cryptware, which is a BitLocker extension, and so on. But also other companies found frequently new vulnerabilities in antivirus products or firewalls. So for example, Google Project Zero, because they find really, really many 0 days the last years. So you see here a big list, and also not to forget the NSA leaks where they found, where they developed a 0-day exploit with unauthenticated remote code execution on a Cisco firewall. So if you're using a firewall, they can hack into your company. And today I want to show you here two very interesting case studies, because I think you can learn many things from these two case studies. So basically everything started when Rashid Tavakoli came to me. He's also employed at ITSEC Consult, and 1 year ago he found some vulnerabilities in carrier control, and it was stuff like SQL injection, cross-site scripting, and remote code execution. And basically to exploit the remote code execution, you need to exploit the cross-site scripting vulnerability before. And Carrier then just fixed the cross-site scripting and SQL injection stuff, but not the remote code execution. So it then came to me and said, yeah, let's hunt again for some cross-site scripting, because then we can again spawn reverse root shells on this firewall, and it's really trivial to find cross-site scripting stuff. So then we started to have a look again at this stuff. And I have here an image how the remote code execution vulnerability is working. Basically, it's administrator. You can here go to the software updates and upload here an upgrade image. And it's basically just a bash file which will be executed with root privileges. So the attack works like you go to my website, it's attacker.com, and I force you to upload the file to your internal firewall system. And then I can execute the stuff on your system. But typically, if you go to my website and I send requests to your website, it should not lead to any action. This is called cross-site request forgery attack. So for example, if you go to attack.com and I send requests to Facebook, it should not lead to any action like sending messages or deleting your account or stuff like that. So for this, you have cross-site request forgery protections. And exactly to bypass this protection, we are using here cross-site scripting. So you see here, this is how you can generate the upgrade file. And you basically just upload this file here, and then immediately this command here will be executed. And you can, of course, change it to any command which you like. And to bypass the cross-site request forgery stuff, we are searching here for new cross-site scripting vulnerabilities. So, for example, if you click on this link here, this code here will be executed in the context of the website. And these are the two vulnerabilities which we identified later on to, again, exploit this remote code executioner. And then we reported this stuff again, and they basically, again, just fixed the cross-site scripting stuff, but not the remote code execution. And to demonstrate them again how simple it is to find new cross-site scripting stuff, we identified one more cross-site scripting vulnerability. And I think this one here was fixed 6 days ago. So every version of the firewall until 9.1.4 is still vulnerable. And the nice thing with this last cross-site scripting vulnerability is that you can also bypass all major cross-site scripting filters from browsers. So for example, Chrome or Internet Explorer will block attacks like these ones here. But with the last cross-site scripting bypass, you can also bypass all these filters. This is how the attack would look like. So the victim is sitting inside the internal network. He goes to my website, attack.com. Then I send him back some malicious HTML JavaScript code, and this code will force his browser to send the requests for me. So he's then attacking the internal IP address for me. And this also means that not a single port must be opened from the internet, because the complete attack is done by the internal network, from the internal network. But here I have many problems. So basically I have to solve 3 problems. The first problem is I have to know the internal IP address of the firewall system. So basically if I want to return here some code to attack the internal firewall system, I have to tell the browser at which IP address the firewall is running. So that means I have to find out the IP address of it. The second problem is that the attacker, the victim must be logged in. And this is, to be fair, not very likely, because you're typically not logged in as administrator on your firewall. So we also have to solve this problem here. And the third problem is the problem with cross-site scripting. As already mentioned, typical browsers, up-to-date browsers, have here protections against this kind of attack. So with the last bypass, with the last cross-site scripting, we can bypass it. But at the time when I was doing this research, we didn't have this cross-site scripting vulnerability. We just found this as response when we see their patches. So to target the first problem, we just have to know a basic possible internal IP range from them. We can get this information from information leakage vulnerabilities like WebRTC or email headers and so on. But even if we don't have this information, we can just brute force everything, and it just will slow down the complete attack a little bit. And because of same origin policy, we cannot read responses. So for example, if you go to my website, I can force your browser to send a request to the firewall, but I cannot read the response. If that would be possible, it would be itself a big vulnerability. So for example, I can send a request, I force you to send a request to Facebook, but I cannot read the response, because elsewhere I could be reading your messages or your bank details or your emails. So this is same origin policy which prevents me from reading the response. So I somehow need a technique to identify if on the testing IP, carrier control is running. And I'm using here the side channel of loading images. So what I'm doing is, I try to load the carrier control logo from all possible IP addresses. If the image can be loaded, I know that on this system, carrier control must be running. That means the onload JavaScript callback will be executed. In the other case, if carrier control is not running there, I will not load an image. That means on error will be called. And this way, I can identify the internal IP address of your system. So I just try to load from every possible IP address carrier control image logo. The next problem is the user currently logged in. So I can use here the same attack again, the same idea. I just try here to load the user image. It's always internal photo. If I can load the image, I know the user is currently logged in. Then I can continue with my attack. If he's not logged in, I can just start a brute force attack where I force your browser to brute force the internal credentials. So I just say, go to the login mask and put in some user, so just send a login request with possible credentials and then load the image. If the image can be loaded, I know the credentials are correct. So this way I can brute force the credentials. And the last problem, so basically as I already mentioned, we already found a cross-site scripting vulnerability where you can bypass all these checks, but at this time when I was doing this research, I just said, okay, for a second attack vector, I don't want to use any kind of cross-site scripting stuff. So I want to make everything completely blind. So what we are doing with the cross-site scripting in the first attack, we want to bypass the cross-site request forgery protections. And we can instead directly bypass their cross-site request forgery checks for the second attack vector. And in the second attack vector, I basically abuse functionality from two scripts. So the first script is called setphp. It contains this code here. So the idea is, I get here the security hash from the victim, from the visitor. So it's from the get parameter or from the post parameter. And then I have the correct security hash, which is the same, which is a random number for the complete session. This is the correct security hash here. And then I just compare, are they the same? That means I just check if the user knows the correct security hash. And I, as attacker, don't know the security hash, and that's why I should not be able to make any action on the system, because I don't know which is the correct security hash. But what Kerry here is doing is they really fail here by implementing this check, because this code here is PHP code and not JavaScript code. So the main problem here is, in JavaScript, this code would really work. Because what they want to do is they just want to get the get or the post parameter. But in PHP, this operator here is a logical OR. That means the result is 0 or 1. That means we have now inside posted hash the number 0 or 1. And the security hash is a string, and then they make here a loose comparison. That means the string here will be converted to an integer, to a number, and then this means the string will be converted to the number 1, then we're comparing the number 1 with 1. That means as soon as I set the security hash to any value, I always bypass this check here. And then I have a second script, content loader, which is required for the complete attack. And this second script contains a different cross-site request forgery bypass. So you see here, the condition is the posted hash, the hash which I sent to them is empty or some condition. And now they change this or to an end. That means I can just come into this failure state if posted hash is empty. That means as soon as I just set the posted hash to any value, I can just bypass their protections. And now I can force any action inside these two scripts, which means I can just make their stuff there, and they can find their stuff like remote code execution, heap spraying, cross-site scripting, and so on. We even have another script which has address-based layer randomization bypass. This is a memory corruption protection, and the script basically leaks heap and stack pointers. And the strange thing is that both scripts, which contain all these vulnerabilities and bypasses, are not referenced by any other file on the complete system. So I don't really know why it is there, and their fix was also to just remove these files. So for the second attack vector, we are using the fact that they are using a 6-year-old PHP binary. And as you can imagine, a 6-year-old PHP is not good because it contains many, many different public known vulnerabilities. And they also make here some unserialized stuff on user input, which is also bad. So what we're doing is now, you can find on the internet some vulnerabilities, public known, inside unserialized. And we're just abusing this stuff here. It's basically a use of the free vulnerability. And it has this C4E number here. And we wrote an exploit for this C4E number. So you see here, inside setphp, you can set any session variable to any value which you like. And then you have the content loader, and the content loader just takes the last displayed session variable and calls unserialize on it. So what I'm doing is I just call setphp with last displayed as variable name and then to just content, and then I call content loader to just unserialize this stuff. There's also some other problems in this code, but I will come to this later. And we are now exploiting a type confusion vulnerability, which leads to a use of the free condition. So for this, we have to understand how serialization is working in PHP. So this discussion is just on this old 6-year-old PHP version. In the newest version, it's a little bit different, but the basic idea is always the same. So you see here, I have an integer, and if I serialize this data, I will end up with this code here. So it's always the same. The first character just tells me the data type, I for integer, then we have double dot, and then the actual value, 1 to 3. The same applies for double values. We have just here double and then the value, or for strings. string, then we have the length of the string, and then the string itself. You can even take a little bit more complex stuff like arrays. So you see here I have an array with 3 elements. Then the first stuff is always the key. So this integer 0 is this key. And then I have here the actual value, 1, 2, 3. And then the key 1, and so on. And if you have a look at the source code, you can also see that we have references. So what you can do is you can add references to it. So it would look like this. If I take this serialized string here and want to call unserialize on it, so I want to get objects back from it, internally PHP will scan the string. So as soon as it comes here, it says, okay, it's an array. Then we have here a reference table. It's an internal reference table. It's called var-hash internally, which just stores all the references to implement the referencing stuff. So it just says, okay, the first object here is an array, so we have just a pointer to this array. Then it continues the scanning. So we just scan here the key and the value. The keys are skipped, just values are appended to the reference table. So the next element is pointing here to the second value. Same again, until we come to some reference, and reference means we just go to this reference table and make a lookup there. So we just go here, reference 3, that means we go to index 3, and this is a pointer to the integer 4, 5, 6. So this reference will be replaced with the integer 4, 5, 6. As you can see here, if we just execute this program, you see here the reference was replaced with this number. And to now understand how this vulnerability is working, we have to understand how PHP is internally storing all objects or all variables. So internally it's using a set file structure, and if you have an integer or a double or a string or an object, everything is stored as set file. So it's basically the idea that the first part is the value, and then you have here a type field, and the type field tells you is it a string, is it an object, and so on. So if it's, for example, type 5, the first value is interpreted as an object. Or if it's type 2, the first value is interpreted as a double. And you also see here that you have a reference count. So that means you are counting references for every object. So for example, if I have a variable and I have 3 pointers on it, the reference count should be 3. And as soon as I remove all these pointers, the reference count becomes 0. That means the object will be freed from memory. And the main problem with all PHP unserialized vulnerabilities is that here this reference table adds a reference. So here we have a reference to this integer here. But the problem is that this reference is not counted. That means you're not increasing the reference count. And this is why all these vulnerabilities are working. It's always the same idea. You have here some data, you add a reference to this data, and you try, between this data and the reference, you try to add some code which frees the data, which just removes the references so that the reference count becomes 0. Then this data is freed, but you still have here a reference on it. And then you can use the freed memory. So the trick is now, how do you find this code from this red box, how you can free the memory? And this is always, for different C4E numbers, always just this part here differs. Just the red part differs. And to free the memory, we are using in this case here for C4E 2014, 3514, we are using here SPL object storage. This is a special object. I don't really have to understand it, how it exactly is working, but basically we have here an alpha object, and this here is added to a hash table. So I'm now adding alpha object to the hash table. That means I'm calculating based on this alpha object some hashes. And let's say it's the hash 1, 2, 3, 4. So at place 1, 2, 3, 4, I have now a pointer to the alpha object. And then I just calculate the hash for the next object, for the beta object, and do the same. Let's say we have now the hash 888, so it's now pointing there. And the main problem is, what is if I generate 2 objects which have the same hash? So I have here a pointer with hash 1, 2, 3, 4, pointing to the alpha object. But now I generate a beta object which has the same hash value. That means I'm now overwriting this pointer here. So this pointer here is no longer pointing to the alpha object. That means the reference is decreased to 0. So alpha is no longer a reference. That means this alpha object is freed. But at the same time, you still have inside this reference table a reference to it. This is mainly because this reference here is not counted inside the reference count. And exactly this fact I'm abusing. So the problem is, how do I generate two objects which have the same hash value? And this should not be possible with two objects, but the problem here is that I'm using some type confusion attack. So if we go back to this stuff here, this here is the input for my hash calculation. And this macro here just says interpret the data always as an object. But because it should just accept here objects. You see here, it should be an object. But the problem is that this stuff here is not checking the actual type. So I can also add, for example, integers or doubles and so on. And what I'm doing in my attack now is I add here a double value. So you see here, this double value. And this double value internally has the same hash as the object, as the D class. So you see it here, the debugger output. This is the input for the hash calculation. And the type is 5. This is exactly for the STD class. And then the double value here has the type 2, but the type is never checked. But it has exactly the same hash value. That means this double value frees this STD object from memory, but I still reference it here with this reference 1. And the next step, what I'm now doing is, you see it here, I'm now allocating. So this step here is freeing the stuff. Now I'm allocating my own memory over this object. And with this reference, I'm now referencing here my own object where I can just say, okay, this object is now a string, or it is an object, or it is an array, or whatever I like. And you can, for example, just say the value is as you like. So in this case, I'm saying I have a string, data type 6, and the string pointer is pointing to the start of the file. So I'm just reading here the ELF magic value at the start of the file. And then you can continue the attack. So instead of using strings, you can use objects, and then you can get code execution. Here you get two problems with major memory corruption protections. So the first one is address space layer randomization. That means if I send something to the application, it will always be at a different address. So the address will be randomized. So I somehow have to bypass this protection. One possibility is to use the information leakage. So you see here, this script here is leaking pointers. But the problem is I don't have the possibility to read these pointers because of same origin policy. So in this case, I cannot abuse it. So my idea was to just spray my data to complete memory. So if my data is at the full memory space, I can use any address because it's always there. Doesn't matter what address I'm using. So I just say, create a session variable called x1 with 8 megabyte value. Create a session variable x2 with 8 megabyte value, and so on, to just fill up the complete memory space. So you see it here, it takes about 24 seconds to spray the heap. And then you see I'm now taking these two addresses, and at these two addresses I have the memory under my control, so I can store there some stuff. So this way I can come across address space layer randomization. And the second prevention is data execution prevention, which means every data which I sent there is just data. It's just marked as readable and writable, but not as executable. So I cannot place my own code there. And to bypass this protection, you just apply return on data programming, which means you're abusing the already existing code and just mark then your own code, your own data as executable. And for this, I'm just executing mprotect, because with mprotect you can just say the data is now executable. That means here this is the rob chain which I'm using. So in this case you see this rob chain just calculates me the base address of mprotect, and after that I just call mprotect on it. I will now show you here the demonstration how this works. So you see here I downloaded carrier control, have it running in my virtual machine. So the victim now goes to my website. So a typical website would not look like this. It would look like a normal website, so the victim would not see that an attack is ongoing. So this is just so that you see that what is going on behind. So I'm now starting the exploit. So the first task is to identify at which IP address carrier control is running in your internal network. So I'm now loading here images. You see here, the carrier control image was loaded from one IP address. That means I now know that at this IP address here, carrier control is running. So this is basically the same IP address. And for example, here the image could not be loaded. That means at this IP address, carrier control is not running. So this way, I now obtain the IP address of carrier control. The next step is to log in. So the first thing is I check if you're currently logged in. You see here, I'm loading your user image. In this case, the image was not loaded. That means you're not logged in. So now I start a brute force attack. So I tell your browser to send login requests here until I can load this user image. Now I was able to load the user image because valid credentials were found. The next step is to make the heap spraying stuff. So I force your browser to send all these requests allocating 8 megabytes of data in the remote on carrier control to fill up the complete memory space with my payload. Just skip this here. The next thing is I call set PHP to set my unserialized data, and after that I call content loader to load my unserialized data to actually exploit the memory corruption. And after that, you see that I get here a reverse shell on the system, and from there on you can attack the internal network. So you see here I'm running on carrier control, and I have root privileges. I can also dump your credentials, or at least the hashes. And this is also the VPN gateway. So I can start sniffing the area traffic or as I like. Here just some quick notes about the vendor response. So this is just the vulnerabilities which we found and abused in these 2 attack vectors. And basically the vendor just responded to us, yeah, the most vulnerabilities will be fixed. And they were also really fast with fixing it. But for example, stuff like web service running with root privileges or the remote code execution is not considered as vulnerability, and therefore they won't fix it. For the first remote code execution, they now fixed our force cross-site scripting payload. So for this one, you need a new one cross-site scripting vulnerability to exploit it again. But the second remote code execution, basically they just removed all codes to unserialize. But the problem is that they're still using a 6-year-old PHP binary. That means there are many, many other PHP functions which are still vulnerable and which you can still exploit, maybe also in the unauthenticated area, so you don't need any authentication. So you just can start some fuzzing against this old version and just exploit it then. And I think we can learn many things from this text. So first of all, also for administrators, that they should also configure strong credentials in internal networks. So we very, very often see in internal network scans that they have very weak credentials and they're always saying, yeah, you cannot exploit this from the internet. But in this case, you can really exploit it. And also for vendors that they should fix the problems at its root and not superficially, like cross-site scripting and not the remote code execution stuff. And also for PHP with the reference counting stuff. And another problem is you should consult security experts at the design phase, because then you can save a lot of money. So for example, if you go a little bit back to the cross-site scripting stuff, cross-site request forgery stuff, so you see here, what Carrier is doing is they extended PHP with their own C code and then using this stuff inside their PHP scripts. So basically they have written everything without PHP, they have written nearly every functionality inside C. So this is exactly this code here with Cario. They get their own C objects and then they're calling stuff like get CRF token on it. And the problem is now they cannot update PHP anymore because their complete code base is running on this one PHP version. And that means it's now very costly to update PHP for them. And that's the main reason why they are not fixing the 6-year-old PHP version. Yeah. I'm now at the end. Thank you for your attention. And if you have questions, you can come after to talk to me or just ask now. Thank you.
Thank you very much, René. I really love the level of detail, how you went really into the exploit for us technical people to be able to understand. Thank you very much for that. Here is a certificate for you giving your presentation. And if there is a quick question, just 1 minute, I'm able to take that. Yep.
To find the internal IP address of that firewall, you were looping through how many IP addresses? Is that C block or higher?
In this case, in the demo, I just used the C block.
Oh.
Yeah.
But
in
reality, it can be anything.
Yeah, exactly.
Okay.
But typically, you're using some information leakage vulnerabilities to just get a base address.
And here's a gift from the organizers. Round of applause again. Thank you very much.